All right, boys and girls, welcome back to the drive-through. Hope everyone's having a good day. Special shout out to my mom. Thanks for the breakfast sandwich. Good old mom. No one better than my mom. Okay, so look, it's very similar to yesterday, but now we're dividing. Some things to remember before you get started, okay? Remember that x to the fifth over x cubed, well, that's the same thing as x times x times x times x over x times x times x, and x over x is just 1. And so that's why you subtract powers. So if you have the same term with different powers and they're being divided, you just subtract. Remember that. So that'll come into play here today. The square root of 75 can be written as, I'll rewrite this here. Well, again, we want to look for perfect squares to take it out of that. So we could write that as the square root of 25 times 3. But the square root of 25 is just 5. So it's 5 radical 3 over radical 3. That gives you 1, and so the answer is 5, okay? Let's keep looking. So, change colors here. Square root of 63xy cubed over the square root of 7y. Okay, well 63 is the same thing as 9 times 7. Okay, I can see where we're going here. So, we'll rewrite this as the square root of 9 times 7 times x times y squared times y. Now, why did I make this y cubed into y squared times y? That's a lot of y's. Well, because what I'm looking to do is to take things out. Well, let me rewrite this. All over the square root of 7y. Okay, so I'm going to take out this 9 and I'm going to make it a 3. I'm going to take out this y squared and I'm going to make it a y. And so that's all we have left. So my next line will be 3y times, what do we have left? 7xy. Let me call this 7yx, and hopefully you can see why I'm doing that, all over radical 7y. Well, radical 7y over radical 7y is going to cancel. And so that leaves you with the final answer of 3y radical x. Okay? Not easy. But it's okay. It's good to be challenged. All right, again, last one. The square root of 54 x to the fifth y cubed over 2x squared y, square root of 2x squared y. What up, Ryan? Okay, so 54 is 9 times 6. I'm going to call this x to the fourth because I can square root that, times x times y. Let's look at what we're going to take out of here. Okay, so square root of 9 is 3. Square root of 6, well, I don't know what that is, so we're going to leave it. Square root of x to the fourth. What number times itself, or what thing times itself is x to the fourth? X squared. Okay, and that's it. On the bottom, there's nothing we can do to simplify it. We have the square root of 2x squared y. All right, so let's organize. On the top, we have 3x squared times the square root of 6x y. And on the bottom, Oh, I lied. I totally lied to you. Look, we have an x squared here, so let's take that out and put an x there. So on the bottom we have x times radical 2y. This one's tough. Okay, well, the x squared over x gives us just x to the first. The square root of 6 divided by the square root of 2 is going to be the square root of 3. So here's what we'll do. Let me change color. This square root of y cancels with this square root of y. This we're going to change to a 3 because it cancels with that square root of 2. So what do we have left? On top we have 3x times radical 3x, and on the bottom it's gone. I can tell you on this first side of this worksheet, if you do it right, the denominator or the bottom of the fraction will disappear. It'll turn to 1. Okay? Alright, so now we're going to move on down to the back. Now it says rationalize the denominator. What that means is no square roots in the denominator. Okay, which is the bottom of the fraction. So, what happens when I come across the square root in the bottom of the fraction? Well, there's only a couple strategies I can ever take in math, and one of them is to multiply something by 1. Okay, we are allowed to multiply something by 1. Okay, why would I do that? So that I can follow the directions, because the directions tell me to rationalize, and rationalize means no square roots on the denominator. So look what form of 1 I picked. I always pick whatever this is. So it's the square root of 5 over the square root of 5. So what is the square root of 5 times the square root of 5? It's 5. I mean, it's the square root of 25. But hopefully you know from all this work, you're getting better at that it's just 5. So on the top, you get the square root of 5y. So that is how you write this answer. Okay? Alright, significantly harder on the second one. So let's take a look at it. 18 x squared y underneath a radical over radical 2y cubed. Okay, well, let's follow the same strategy. So let's multiply this by 1. And in this case, we're going to multiply it by radical 2y cubed over radical 2y cubed. Okay? What do you get on the bottom? You get 2y cubed. On the top, you get a square root of 36 x squared y to the 4th. Okay? Alright, well, what's the square root of 36? 6. What's the square root of x squared? X. What's the square root of y to the 4th? What times itself gives you y to the 4th? Y squared. The entire top is out of the radical now. That's nice. You get 6x y squared over 2y cubed. Okay? 6 over 2 is 3. X stays. The y squared is gone, and this becomes a y to the first. So what do we have left? 3x over y. And that is tough. Okay? Stick with it. It's nothing wrong with practicing and making mistakes. Okay? It's part of math. You haven't had to do it a lot lately, but it's certainly going to happen here. Let me give myself some room. The cube root of 7x y squared over the cube root of 4x squared. Okay? Alright, we're going to stick with the strategy. So when we rationalize, we multiply by 1. What form of 1 are we going to do here? The cube root of 4x squared over the cube root of 4x squared. I am allowed to multiply things by 1. Why am I multiplying things by 1? Because I'm following the directions. It told me to rationalize, and rationalize means no radical in the denominator. So here we go. On the top, I get the cube root of 7 times 4 is 28. Oh, this was a dumb way to do this, but I'm just going to do it. I could have just simplified the bottom right away. That was so dumb. But oh well. X cubed y squared over 4x squared, because, sorry, cube root, yeah, that's right. No, is that right? Cube root of 4x squared times cube root. No. Pause. Okay, I just realized that I've never done one like this before. And so what we have to do is undo this first strategy. Okay? We've got to multiply it again by the cube root of 4x squared over the cube root of 4x squared. Here, let me just get rid of this for a second. Because it's not a square root anymore, it's a cube root. So since it's a cube root, we need to multiply it a total of 1, 2, 3 times to get rid of that little bar. Okay? So this is going to get really funky. I might end up telling you to skip some of these, but we'll keep going on this one at least. So now we got to do a whole bunch of multiplication. On the top, we have the cube root of 7 times 4 times 4, 16 times 7. I just am not smart enough to do that, and I don't want to get it wrong. So you get 112. You got x times x squared times x squared. So that's x to the 5th. And y squared is the only y squared in there. Okay, and on the bottom, you have 4x squared. Why? Because 4x squared times, because the cube root of 4x squared times the cube root of 4x squared times the cube root of 4x squared equals 4x squared. That's kind of weird. Now, do I want to keep going? I guess I will. Is there a perfect cube that goes into 112? Well, the perfect cubes are 8. So let's try 8. No, it can't be 8, right? Oh, yes, it is. All right, here we go. So, we're going to rewrite the top as the cube root of 8 times 14 times x cubed times x squared times y squared, and we will rewrite the bottom as 4x squared. Just rewrite the bottom, okay? Next step. The cube root of 8 is 2. So we'll pull that out. The cube root of x cubed is x, so we'll pull that out. There's nothing else that we can take out, so on the top we have 2x times the cube root of 14x squared y squared. And on the bottom you have 4x squared. We're not done yet. The 2 is gone. This becomes a 2. This x is gone. That x squared becomes an x, so our final answer is square root of 14x squared y squared all over x, cube root here, okay? And now we have one more example to show you guys, okay? Don't worry, I'm going to let you skip some of the homework. We don't need to be doing all that stuff all the time. Okay, this is a good one. This is actually what we should be doing more of, okay? Problems that apply, especially to geometry, to help us remind ourselves how to do geometry so we can do well on our ACT and SAT that's coming up at the end of this year. So the area of a rectangle is 30 meters squared. The length is radical 75. So we know that the area is 30 and that one side is radical 75. They want to know what the width is. I don't know what the width and length is, and it doesn't matter. Okay? So just start with your formula. Area of a rectangle is base times height. You got three variables there. We have to know two of them. So we do. 30 is radical 75 times x. So now this might make sense why we're doing this. How do you solve for x? You divide both sides by radical 75. Okay? So you get x is 30 over radical 75. Multiply both sides. Well, let's change this to 30 times radical 25 times 3. Square root of 25 is 5. So it's 30 over 5 radical 3. Does it tell us to rationalize the denominator? Yes, it does, because it's part of this. So 30 divided by 5, that gives you 6 over radical 3. Now we have to follow these directions that say rationalize the denominator, but that's okay. We just multiply by 1. What form of 1 do we choose? Radical 3 over radical 3. On the top, we get 6 radical 3. On the bottom, you get 3. 6 divided by 3 is 2. The answer is 2 radical 3. Oh my goodness. Let's stop this video. Boom!